Hello! Today we are doing problem 6, merge two sorted lists. And yeah, so this one's interesting because I usually try to record a video, within like a day or so after I understand and the approach to the problem. But this time I waited 3 days because it was the weekend and we were busy all weekend. So I'm kind of doing this to see if, like, a few days later, will I be able to just go, oh, right, and then kind of like register what the approach is and, like, look at the code and go, yeah, yeah, okay. You know what I mean? So, and trying to explain it from there because it's more fresh in my mind, but this time it's not. So we'll try this. And I kind of didn't. So there was like a bottom notice that says it is strongly recommended to do merging in place using constant extra space. So I was like, oh. I think the code I have is constant, but it was really confusing. Because it's like sometimes they just create a new linked list with the two merges, and then whereas other times it's like, oh, just switch up all the pointers and stuff. So I don't know. It was like I'm pretty sure this is, but well, I'm pretty sure. So the prompt is given two linked lists sorted in ascending order. So we know about the problem is that it's sorted, their linked lists, and we don't know their inputs. Like it could be negative, it could be whatever, but yeah. And our goal is to merge them in place and return the of head of the merged list. So our goal is to merge it with no extra space and just return the head. So because we return our head, we return the rest of the list. So the example given is a node of 10 and then 20 and then 30. Let me just double check this is recording. Cool. Okay. And then 30. That looked like 36. I'm going to retry it. And the second list is the second input. So there's two inputs. 15, 17, and I don't actually know if these line up or anything. I'm just saying, that's how I'm gonna draw it. And then our goal output would be the merging of these two lists in order, which is 10, 15. Really should have drew this out before. It saves so much more time. 17, 20, and 30. And that's sort of it's ginormous 20. And that's sort of our goal and put. That's kind of this problem setup, and I drew it out because I think I'm going to need to in order to explain it. I'm gonna have like just a bunch of pointers and stuff going all over the place. So yeah, let's see if I remember. How much do I remember? Even yeah. Input. Okay. Let's see. Linked list 1, linked list 2. Oh man, it's so messy. Blah, 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 blah. It is strongly recommended to merge using one's complexity, space complexity. Okay, so and it's a singly linked list. Okay, so the approach. So I think the brute force way would be. I don't remember. This was a couple days ago. But my initial. I don't remember my initial thinking too much, but my initial thinking was okay. We could convert this to because we're linked list. We gotta traverse through the array and stuff. Yeah, but which usually at a time like this is like, okay, 2 pointers. We're using 2 pointers. I know that. And then, but the other solution was like, well, I could convert both into arrays and sort the array and then convert it back to a linked list. And it's like, does that work? You know what I mean? But I know that it would not be optimal. So I was like, okay, the solution has to lean somewhere into 2 pointer territory. But I mean, 2 pointers doesn't disturb the space. So I know that I was on the right track. And I don't remember what happened after that, just because it was a few days ago. So, but we are using 2 pointers, and um, you could. So I'll just write up the code, but there's the so we've used 2 pointers and dummy nodes before as strategies to like decrease code complexity and improve performance and stuff. So we're using that here. Um, I think my struggle actually with this one was um, what exactly does a dummy head like help with? Like, you know what I mean? Like, I know it helps. Like in my head, I'm like, yeah, it would, some decrease some like edge cases and stuff. But what are those edge cases? So, like if there is, so someone just like write out the one without the dummy node approach and with the and one with the dummy node approach, and I could see it, then I would have a better idea of like, okay, exactly this is what it's good for. So this is what the solution is. Um, and yeah. So let's write. So our general approach is we're going to like what is it? Kind of like a weaving pattern. So we're gonna create, I mean, this approach doesn't, but we can, it's very easy. So we're gonna have create a dummy node, and the dummy node will become the head of the list. So head dummy right here. And then we're gonna start our weaving through by comparing the first value of linked list 1 and first value of linked list 2. And going, okay, which one's smaller? Because the smaller one I'm going to connect to. So, or just, actually we have to do it in constant time. So like adjust to. So it would be like that. Like we would pick 10 because it's smaller than 15. And then from 10, we're going to increment the pointers. And go, okay, now we're comparing between the first the linked list node of 2 and the second linked list of 1. So 15 versus 20, 15 smaller, so we're going to adjust the pointer down here. We're going to make that into the temp head, and then we do the same process again since the pointers have adjusted, and then we're going to move the temp to after before we compare. I mean after we compare. So where does it go now? Right. Okay. It goes 17 versus 16. So it would go to 17, and then now. Oh right, I forgot this part. So it doesn't really set it, but it's supposed to. Oh crap! What do I do? Uh-oh. There you go. Sorry, I don't know what that was. I don't know what that button was. I hit something. Man, that was ugly. Sorry. I forgot this is pointing to null. This points to null. I always forget to draw these. Okay, so and it helps me when I draw it. So and now we've the temp is now at null after we incremented, and we're like, okay, now this is here. So all we have, naturally, the only place we could go is 20. So, let's change my colors. So it would be 20. Oh my god, I changed my colors! I'm sorry, I'm dealing with some chest pains. I go to 20, and it's been bothering me all weekend. And then, from here, because there is no because there's no what's it called? I mean, we hit the end of linked list too. So our obviously there's nothing to compare to. So we're just going to return the rest of this list. So we're just going to return the rest of 20 to 30. And if whatever values after the 30. So our code has to reflect that. Once one of these once the one of the linked list hits null, we have to just return the other ones in full because they're already sorted. So we're allowed to do that. We don't need to sort anything. We could trust that they're already sorted. So yeah, and yeah, that was my explanation. Hopefully that makes sense. So I'm gonna write the dummy node solution without the dummy node, and I'm gonna say, okay, which part I could take off because the dummy node, um, that's what like helps with instead of having to write two sets of codes that are very much the same. So I'm gonna define. Oops, probably should write it in white. And it was a few days ago, so I don't actually. I think I don't remember exactly what the time complexity is, but I'm pretty sure it's linear O of n because we're using two pointers transverse through. So I'm pretty sure. So define merge to this, and then we're going to what's it? Have I don't know if it should be a lowercase l or uppercase l. List so inputs parameters of linked list 1 and 2. Sorry, I'm like brain farting here because my daughter's making weird noises on the monitor and I thought she was asleep. So let's hope for the best. I don't want to get interrupted. So merge two lists. Yeah, okay. And we have to make sure that we cover our edge cases, which, first of all, I think they're all about the same. So, edge cases, I'm just going to write this down to help myself remember. So, usually it's like, okay, check if empty, because if it's empty, what's the point of doing any of it? If empty, oh, I wrote it on a list somewhere. I mean, I wrote it on a note somewhere. Let me look it up. It's good to remember these kind of cases. Seems like pop up a lot, especially with linked lists. Um, 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 if the data is actually empty, we're going to assume it's actually sorted, right? um, and if items both being swapped is the same. Well, I don't know if that's going to be the case. So I think, oh, I know. If it's, oh, I know. Yes. If there's no, we still have to merge. Um, oh, we have to make sure if one of them's empty, not just is empty, is if one of them's empty, because then we could just return the other one. If empty, return one. No, I mean return one of them. Return, I don't know, or if they're both empty. So we have to make sure that we return the other one if it's one of them, if the other one is empty, and we to return none if they're both empty. So it is slightly different. So we're just gonna erase this. I don't have enough space to write all that then. But yes, check for empties. Empties, then return. Or return none. Okay. Or if they um uh If there's only one value in the, so I guess it has to be more than one value, as otherwise that's a pretty easy merge to do. And you should know, I guess, where to start, which is kind of annoying. That's what the dummy head would help with, because um, but we have to pick a sort. So I did a dummy head, right? But if I didn't have a dummy head, I would have to compare 10 versus 15 and then figure out which one is first to go to start weaving through, and assign the temp head to that starting point. You know what I mean? So yeah. Um. Uh, okay. I'm not the best at explaining this, but hopefully that makes sense. And well, that isn't really an edge case, really. So I'm just gonna delete this, and I'm gonna proceed in writing the code quickly because I'm out of time. So this is the edge case if length plus 1 equals none. We're just gonna return the second one, and vice versa if L2 equals none. Yes, I know the writing is terrible. It is terrible. Return 1. So yeah, that's a 2. That's supposed to be a 2. And well, I guess we could, with this portion right here, we could dodge it if we have a dummy head. But since it's here, if L1 is, I mean, it's basically the same thing as what I wrote above, except it covers, it covers if they're both or whatever. Obviously, with dummy head, I could avoid this, but whatever. And link list 2 is none. And return none. I think it's good to write out the edge cases because I'm still a beginner, you know? So to me, I'm just like, okay, the dummy heads are more efficient. But how exactly are they more efficient in terms of coding? So yeah. So if intuitively it makes sense. If like this dot val. So this part is deciding where we're gonna start by just comparing the first um first nodes, the first node. So we're gonna say head if the value of the first node on in the linked list is smaller or equal to whatever, then we assign the head to the linked list one, which because it's smaller. And then we're going to increment and go from linked list one and continue the rest of our journey through the linked list with two pointers. And this is basically an else statement that states the same thing, whereas we just kind of if the head is not, then that means that linked list 2 is smaller. So then we assign that as a head, and then we're going to increment linked list 2 to the next one, to the next node to the next one. So yeah, and so this portion could be taken care of, could be mitigated, I guess, by a dummy node. It's just easier because then you could just loop through the dummy and not have to worry about, oh, what if it's not no, because we just have a dummy head in there, and that will cover if one of them is none, because it can't be both none if there's a dummy head in there. So yeah, obviously that's why it's useful, because look how long it took to write that. That is very annoying. Okay, and then the next goal, very important. Now that we have 2 pointers, we need to make a copy of the head. So we make a copy of head, I'm gonna run out of space, which is not something I expected. So I'm just gonna erase this. I'm gonna run out of space, man. Oh crap, I'm gonna run out of space. Whatever, I'll worry about it then. Nope, that is yellow. Oops, what am I doing? No, please don't destroy the display. Okay, I almost exited out the entire browser. That would have been bad. That would have been bad. That would have crashed everything. Okay, I don't know what to go from here. I don't think I need. I don't think I need to because because these are just a bit edge cases um and stuff. So I think it's we could delete it. We already know what's gonna happen if any of these situations arise. It doesn't because our input data is right here, so we know it doesn't affect us. I'm just gonna delete, and then oops, it's not that much delete. Um, so I'm just going to because I'm gonna need all this space, like not I'm gonna need all this space. It's long code because there's so many else if and while loops and stuff. I feel like I probably should have made it a little more succinct. Okay, so okay, I see the beauty of linkless dummy nodes now because I'm looking at this and I'm like, this is. I mean, I'm writing. There's like 9 lines that I need to write out, and I need to squish in here. That's a good lesson. Yeah, it's really long. So I think we should just use the dummy. We should write the dummy head code because it's just so much more. It's slimmer because it's not. We have to cover for cases if um it's ask if linked list the list one is not none, then we have to move forward and increment that way. Well, actually, it's not that much of a difference. Okay, I'll just blend the two. Um, so, gosh, I shouldn't have talked so much. I forgot what was I doing. Okay, so after we covered our edge cases, so then we, you know what I should have done? I probably should have deleted the drawings. I don't know. Okay, whatever. So we're going to, as I said, the continuation from after now we have like finished declaring our not base, edge cases. Um, then we're just gonna go temp. So we're gonna, like I said before, we need to make a copy of the head. So we're making a copy of the head, and now we are going to use that to go while link this one is not none and link list 2 is not, I'm just gonna write, yeah, no, I'm done. I'm just gonna write while link list 1. I think in Python you could do that and link list 2. So that would just automatically mean like while if it's not none. So while link list 1 and 2. Then we're gonna go okay. If linked list 1's node value is less than 2, 2's about what is happening? Value. Is it because I'm applying too much pressure? Why does this get so bad? Oops. Okay, here we go. Then temp dot next equals link list 1, and then move on from link list 1, the node of linked list 1. So yeah, now we're just judging for which one is smaller, and then no matter what, we have to move the temp head. So equals temp dot next So while linked list 1 and 2 have values, we're going to compare the two values, and we are going to thread whatever temp from that smaller value, and then move the pointers at linked list 1 to next, or move the temp to next one. And yeah. Oh no, wait. See, no wonder I skipped. I thought we write it afterwards. We don't write it afterwards. We write an else. I was like, wait, what's going on? What happened to what if it's not smaller then? Okay. Then we're going to, here we go. That makes more sense. 10. I guess scattered brain sometimes. If not, then if it's not smaller and it's bigger, then we assign the next one to the smaller, which is linked list 2 possibly, and then linked list 2 we're gonna go, okay, next one for you. You know? Yeah. Considering this is like a couple days ago, I'm actually remembering a decent amount of it. Yay! And then we're gonna go, okay, temp equals temp dot next, because we gotta move the head. We have to temp head, otherwise it would mean, yeah. No matter what. So this is on the same indentation. Okay, now we go. Well, I guess that's the code. So, but we have to. So, just the while loop will loop through all these things here and do its thing, and then we will be ending up at null. At which point we gotta go. Okay, let's link this. This video is taking way too long. I forgot what I was saying. And then we have to go, okay, like if we reach, if we hit null, so, well, there's a couple ways that we could say if not none, or, so we could do another while loop like here and then write an else statement. So it'll be like, okay, if there's, we have to write, if one of them goes to null, then what's the other one going to do? Well, the other one's just going to return whatever's the rest of the other one, if they happen to be different lengths. So I'm just going to write this in a more succinct manner than what I originally wrote. So if list 1, then oh wait, sorry, not sorry, temp dot next. Oh my god, what is this? Patience. This is taking way too long. Next, and that would be list 1. So if list 2, temp, we do the same thing to list 2. If whenever they run out, one of them runs out before the other one does, then we just return, we just increment through that one, and then it's already sorted, so we just add that onto the one we did, like this, and then go here, and then go here. Yeah. So yeah. And now we've covered for that. In case that happens, now we're just going to return the what's it called? Head. Sorry. So yeah, now I'm gonna return head because temp was the threading, and the scout. They should go out. The head is still the same, and the head has all the pointers you adjusted now, like a thread through two seams. Is that what they're called? Seams? I don't know. And then we just return head. Yeah. So that's the code that would take care of things, and it would do it in line with no extra space. So time complexity is this. Oh my god. What is wrong with my pen? I'm so sorry. Okay, this is lame. Ugh, like half this video has been struggling with this pen. Oh my god, why is it not letting me? Okay, I'm just gonna say it. I don't need to write it. I'm just gonna say it. It's. Ugh, what is seriously wrong with this pen? This is like the worst. It is not registering my strokes. Space is. Okay, there you go. That was frustrating. I'm sorry. I swear I'm not pressing any buttons or anything. It's just being like this. Okay. Okay. That was cool. We did it, using two pointers, which cut down because it would have been like quadratic time or something. Now it's linear time, and then it's constant space. Cool. Bye.